Hello students, in this video we will learn about potentiometer, how that can be used to find the internal resistance. You know that there is a cell. The cell has inside chemicals, electrolytes, then anode and cathode. You find that inside the cell there is a small resistance to movement of the ions and the electrons, and that is called internal resistance. And the current comes out from here, right? It goes to the external circuit. Let us say I connect it to something, a bulb or something, and that is called external resistance. And if this is the positive terminal and this is the negative terminal, you will find that the current flows from positive terminal and comes back to the negative terminal. Now two things we have to be clear. If current flows through the external circuit, then what you measure across the cell, that will be potential difference. Whereas if the circuit is open, no current is flowing through, then it will be called EMF. We have to be very clear about that concept before we proceed to this. I would like to say that current according to Ohm's law is V upon R, and the same current, I say epsilon EMF of the cell, then I have to include the internal resistance. But both of them the same current only, so I can compare V upon R is equal to epsilon upon R plus R. Now what we can do, we can cross multiply. Okay, take this up and take this here. You will find that epsilon, keep it epsilon here only and bring V down here, right? Epsilon upon V will be equal to, here R plus R will reach over here, R plus R will go up here and divided by R. I hope you are clear about it. Yeah, I have cross multiplied it, right? Epsilon I retained in its same place and I brought the V down here, and when V came down, R plus R went up. So there is a cross multiplication of the factors. Now R upon R, what is R upon R? That is 1. R is a common factor. So small r upon R plus small upon capital R is equal to epsilon upon V. Yes. Now from this I can say R upon small r is equal to capital R is equal to epsilon upon V, plus 1 goes that side, it will become minus 1. From this I can conclude the internal resistance is equal to epsilon upon V minus 1 of that R goes up here into capital R. So this is the formula I need to use now. So taking that formula, right? And what I am going to do, I am going to remove all this stuff here. Fine. Now let us see how we can use the potentiometer to calculate that internal resistance. Right. Now again primary circuit is same. There is a battery, there is a key, ammeter for current and rheostat for variation of the current. Point A and point B, two extreme ends. Now here I have got only one cell whose internal resistance I have to calculate. Very simple here it is. When I connect the cell here, I have taken another small resistance box. This resistance box is the external resistance which I will put. When I say external resistance, that is nothing but a load. When it is a load, that means current is coming out. That means what I measure will be potential difference. So I have got another key here called K dash. When I keep the key open, this does not come into the circuit. Then what I measure will be EMF of the cell. And again galvanometer will show deflection. And I will check with the jockey what is the balance length. You understand? Now epsilon will give me the balancing length. Let us say the EMF is directly proportional to L. That is the principle we studied. right? Let us say it is proportional to L1. Call this as equation number 1. In the next step, what we do, we put an external resistance, let us say 5 ohm or something, we are going to add now. Look at here, the primary circuit we are not touching. I set here 1 ampere, that means I will not touch till I complete 2 sets of reading. A set of reading I am going to take now. So, in the resistance box, I have placed external resistance, let us say R. That means I open the key, I on the key, I close the key. When I close the key, what I will measure will be potential difference. When it measures the potential difference, what you get in the galvanometer in the jockey here, it will show you the balance length. Again, calculate the balance length by moving on the jockey like this till here 100, 110, 120, 130. Third wire 200 something, then 320, 340 till 400. So whatever the value comes, you write that, and that is V, the potential difference will be proportional to L2, some other length L2. Remember carefully, our aim is to calculate the internal resistance of a cell using potentiometer. We know this is the formula. So simply let me write epsilon upon V is equal to L1 upon L2. Call this as equation number 3. And previously we have derived that small r is equal to epsilon upon V minus 1 into capital R. So let me write r is equal to epsilon upon V minus 1 into capital R. Now what is this capital R? Capital R is the 5 ohm which I put in the small resistance box, right? And that is known to me. What is epsilon upon V? L1 upon L2. Through the balancing length we have got it. So R is equal to L1 upon L2 minus 1 of capital R. This is the formula for finding the internal resistance of the cell. And this is very important derivation for you to remember, and also practically it's very useful for you to know. And also you will be doing numericals based on this formula, and it's not so difficult. Internal resistance inside the cell, external resistance outside the cell. External resistance can be load, it can be a fan, it can be a bulb, it can be a motor, anything. The current is drawn out, right? And that is called external resistance. Here the resistance box is offering the external resistance. When I switch on the key, when I plug in it here, then the circuit will become closed. What I measure will be the potential difference, and that will give me a balance length, that is L2. And EMF first I did with the key open, right? And that gave me L1. L1 upon L2 is epsilon upon V. And that I used it directly from here to here. And this is the formula. Practically also you can do and get the result. With that, I am completing this unit on potentiometer. Previous video we saw comparison of EMF, and in this video we have seen how to find the internal resistance. Thank you so much.